All right, this is the video for chapter 1, and it's basically on atoms and elements. This is kind of an outline of the chapter. The first part of this chapter is just to kind of talk about the study of chemistry, what chemistry is. We're going to also talk a little bit about the scientific method. And book is about atoms first. It's a different approach than a lot of chemistry books. A lot of chemistry books start off with the math. We're going to start off with the chemistry. We want to teach you chemistry first, and then we'll get to the math later throughout the semester. All right, so it's going to talk about the atoms and the subatomic particles and kind of how the atom kind of was all developed and the theories behind it. And then we'll talk about the elements in the periodic table. The periodic table is kind of like our Bible in this class, and the organization of it. It's very well organized. And then we'll go ahead and start talking more about the nucleus of the atom, and we'll talk about what isotopes are, atomic number, atomic mass number, so that you'll kind of have an idea as to the start of this course. And like I said, if you have any questions after the videos, we will answer them when we meet again in class. All right, so first, chemistry. What is chemistry? Why do we learn chemistry? All right, chemistry, as it clearly says up here, is the study of matter. All right, study of matter and the changes to matter. Okay, so what is matter? Matter is pretty much anything that has mass and occupies space. All right, so we are forms of matter. Your car is matter. Anything that has mass and space, even the air around us that we're breathing, is considered matter. It's a very small amount of matter, but it's still there. All right, the oxygen gas is there. If you condense it all down, it will have a certain mass. It won't weigh that much, and it does obviously occupy space. It occupies the space of the room. All right, and mass is one of the ways that scientists measure the amount of matter. Okay, there is this thing, the difference between like mass and weight. Okay, there is a difference between mass and weight. Weight is the effect of gravity on the object. Okay, so we weigh less. It's a force. It's not the amount of mass. Okay, mass is the amount of matter inside a person or inside an object. Amount of matter. Okay, weight is the effect of gravity on the matter. All right, so your mass is the same whether you're on the Earth or the Moon. Your weight, however, is not the same if you're on the on Earth or the Moon. I believe the Moon is about 1/5 of your weight than you are on the Earth, but your mass is exactly the same. Okay, so in science we talk about mass, so it doesn't matter where you are in the universe, your mass is the same. Your weight, however, is not the same. Okay, and it's sometimes called essential science because this is one of the only sciences that actually kind of crawl into all other types of science. Okay, and it doesn't matter, you know, here they kind of show you in physics, biology, geology, ecology, oceanography, climatology. Like, you know, some people say that physics or like biology are kind of essential science. Well, I don't really see them too much in geology. Okay, you know, geology is about rocks. All right, and you know, rocks are made of chemicals. So chemistry is really essential science. It's in everything. Okay, a lot of people say, why do I need to take chemistry? Well, if you're going to take another science course, I bet you there's a chapter in chemistry. I kind of joke around with the biology instructors. You know, they say, well, biology is more important of a science, or is essential science. I'm like, well, in my chemistry class, I don't teach any biology. But in the biology classes, there is a chapter or two on chemistry. All right, every class, it doesn't matter if it's physics, geology, anatomy and physiology, microbiology, all right, all these classes, there's always a chapter on chemistry. So it just goes to show you, chemistry really is the central science. Okay, so scientific method. This is actually what makes science a science. All right, a lot of people say, you know, oh, this is a science. Well, if you don't follow the scientific method, it technically is not considered a science. All right, so if your theories and your laws are based off of what I'm about to talk about the scientific method, then it's technically considered a science. Okay, so what is the scientific method? There are several parts to it. The first part is an observation of some sort. Okay, you have to have an observation, all right, of some sort of natural phenomenon or a measured event of some sort. Okay, now your book uses this as an example that milkmaids don't contract smallpox. I think it's kind of it's actually an interesting story of smallpox and the discovery of how we kind of eradicated smallpox, a vaccine of smallpox. So that's kind of what they use. It's kind of an interesting, example, but I think it's a pretty good example of the scientific method. Okay, so we're going to be using this observation about milkmaids and smallpox as our example. Okay, but first of all, it's some sort of observation. It doesn't have to be like milkmaids that don't contract smallpox. It could be, I don't know, like an eclipse. All right, we just had an eclipse, so there's some sort of observation. We kind of have to explain it. Okay, but here the observation is milkmaids don't contract smallpox. Milkmaids, what they're implying are individuals who milk cows. That's what they're talking about, milkmaids. So they found out, this was over a few hundred years ago, I think maybe 150, 200 years ago. They found that women that milked cows, I think back then, I think it was mostly women who milk cows, did not contract smallpox. Smallpox was a huge epidemic over 100 years ago. Nowadays, it's really not, but back then, it was huge. It killed, millions of people. But they noticed that the women who were milking cows never contracted smallpox, nor did they die from smallpox. That was a pretty interesting observation. Everybody else died of smallpox except women that milk cows. Well, why is that? That's a pretty good observation. So hypothesis. So they had to come up with a hypothesis. So that's step 2 in the scientific method. The first one is some sort of observation. All right, I'll kind of keep track of this as we go along in our slides. The second one is the hypothesis. We have to come up with some sort of hypothesis. Now, this can change, right? It kind of shows you that the hypothesis is revised based on experimental results. Okay, so you might come up with some sort of hypothesis, but then when you do the experiment, it fails. So what happens? You have to go back and redo another hypothesis. And this can keep happening several times. Okay, so here is a tentative explanation of why milkmaids did not get smallpox, is that the milkmaids contracted what's called cowpox. Cowpox is a much, much more mild form of smallpox. It's not really smallpox, it's cowpox, and cowpox is a much weaker form of smallpox, and it really didn't kill people. I don't even think it killed cows, because I think cows had the cowpox. And cowpox usually show up on the udders of cows. So as these women milk cows, they are being exposed to the cowpox that's on the udders of the cows. So what their hypothesis was, is that these milkmaids are milking cows, they're being exposed to cowpox, and the cowpox is a kind of form of smallpox, and the body was building up some sort of natural immunity towards the cowpox, which in turn was building up an immunity for the smallpox. Now, in reality, this is true, which is really cool, of how they came up with the vaccine of smallpox. So that's kind of what the hypothesis was. It makes total sense, and it's because it is true. But there were several other hypotheses. I don't know if that's the plural, hypothesi. I don't know what the plural is, but anyways, this was eventually, so it's, was the reason, and that's what their hypothesis was. So now they had to come up with some sort of experiment to experiment this. Now, nowadays, this would not be acceptable. The experiment was to intentionally expose healthy children to cowpox. So I don't know how they did that. I don't know if they had the kids like all come in to like a dairy farm and milk cows that had cowpox. Whatever they did, which, like I said, with child laws nowadays, I think these people would be arrested, but this is besides the point. This was a few hundred years ago, or 100, 150 years ago. So they had intentionally exposed healthy children to cowpox to see if these kids would, and then they exposed them to smallpox. Once again, it just keeps getting worse. But besides the point of it, as if this is a moral issue, this is what they did. They exposed healthy kids to cowpox and then later exposed them to people that had smallpox to see if they would get smallpox. That's the experiment. Obviously, if it failed, which luckily for those kids it did not, then if it did fail, they would have to go back and redo their hypothesis. So the next part was experiment. You know, I'm trying to make it interesting by joking around, but this seriously is what they did. All right. So observation was milkmaids don't get smallpox. The hypothesis is because they were exposed to cowpox. The experiment was to expose healthy individuals to cowpox and then later expose them to smallpox to see if they would get it. Okay. So the model, they call a model, or the theory. So the theory is a set of conceptual assumptions that explains data from accumulated experiments, predicts related phenomenon. So the theory is because the children did not contract smallpox, lucky for them, they were right, the immunity seemed to have resulted from cowpox exposure. So cowpox was a safe way to expose people to a disease so they can build immunity so that they would not get a worse disease such as smallpox. Okay, so the theory is kind of what comes out afterwards. All right, then there's further experiments which can be conducted. Also application, your book does not talk about it, but there is an application part to it. So depending on whatever your hypothesis is, like for example, I want to make a phone that you don't have to attach onto a wall, okay? So a cell phone, okay? Or I have a theory about electromagnetic radiation. That might seem fancy to some of you. A lot of you might have heard of it. But basically, electromagnetic radiation is how our cell phones work. They work on radio waves, all right? Well, you have to first you have to discover radio waves, and which were discovered probably 100, 150 years ago. And then an application of using radio waves is using a cell phone. So that's an application of a scientific discovery. Okay, so the further experiment is to test the predictions based on the model to further test it. So another group might do the same thing, or they might get more people. So especially when you're doing a vaccine, this was a small group of children. Maybe what they'll do is they'll get a whole town. The whole town will come in and milk the cows and expose themselves to cowpox. And if nobody in the town gets smallpox, that was further experiment, and it proves the theory even more. Okay, so this is kind of the scientific method. Number one, you have the hypothesis. Okay, I'm just kind of giving the order. You have the, you have the observation first. You first have to have an observation. Why is the sky blue? All right, hypothesis, whatever your hypothesis is. Maybe there's a bunch of Smurfs that are flying around in the air and they're blue color, and if they're wearing their shorts, those are the clouds, so white shorts, whatever. All right, again, trying to be funny to make this interesting. Hypothesis. Then you have experiments, all right? And if your experiment does not support your hypothesis, you have to go back and redo your hypothesis. Finally, if your experiment does, you have a theory, all right? And then you do further experiments or an application. Further experiments, and then maybe you have an application for it. Obviously, the application here is to vaccinate people so that they do not get smallpox. Okay, so this is kind of the scientific method. Every scientific theory has to follow these rules. If you do not follow these rules, if you just have a hypothesis, okay, if you just have a hypothesis, and like you say, the Earth is square, okay, well, you have to have an experiment to prove that. If you don't, if you just say, no, you need to believe me. If you do not believe me, then bad things are going to happen to you. That's not a scientific method. Okay, there's nothing wrong with believing that the Earth is square or is a cube. Just prove it to me. If you prove it, then hey, we're cool. If you don't prove it, it's just a hypothesis. It means nothing. Okay, so 1.2 is atoms. I mean, chemistry is about atoms. Everything is made up of atoms, all right? And like I said, this book is what's called an atoms first approach, so we're going to learn about atoms first before we start getting to the math. Okay, so atom is the smallest quantity of matter that still retains properties of matter. Remember, matter is occupy space, mass, and space. Okay, so it's the smallest quantity. You can't break by chemical means an atom down any further. I mean, you can, like everyone knows that if you take an atom and you split the atom, you have a nuclear bomb, but that is a physical means. We're talking a chemical means. Basically, if you have a carbon atom and you're holding it, you can't break it down any further by any type of chemical means without splitting it, which would take a lot of energy to do, or a neutron or proton to do it. But pretty much, an atom is the smallest quantity of matter. All right, and then an element is a substance that cannot be broken down into simpler substances by any means. So, for example, if you have a carbon atom, I can't break that down any further than a carbon atom. A carbon dioxide molecule, however, I can break down into carbon atoms and I can break down into oxygen atoms. But these cannot be broken down anymore into any other types of elements. Those are the simplest forms of elements. Okay? And this is going to be the end of video 1.